Okay, another problem here at the end of chapter 8 slides. This one says, if 3.5 moles of oxygen has a volume of 27 liters at a pressure of 1.6 atm, what is its temperature in degrees Celsius? So, again, let's go through and label. We have units of moles, so this is going to be the variable N, which stands for the number of moles of gas. It has a volume, okay, so we're told this is the volume. And then we're given a pressure of 1.6 atm, and we're looking for T, temperature. So this cannot be the combined gas law because we have a variable for N. Now, remember, we have another gas law, which is the ideal gas law, okay? And it's PV equals nRT. So we're looking for temperature, which means first we need to get temperature by itself. So I'm going to divide both sides by N and R. Cancel. And so what our equation ends up being is T equals PV over NR. Okay, so the first thing you want to do is remember what R is, and that's something that I wanted you guys to memorize. So it's 0.0821, and the units are liters times atm on top per mole times Kelvin. All right. So the next thing you want to do once you've written out R is you want to make sure that the units given in the problem match what's on R. Okay, so if we had like milliliters instead of liters, we would want to convert that to liters. All right, but we're given liters, so we're good. We don't have to do that. If we had something besides ATM here, we would want to convert that to ATM before you plug it in. But everything is actually in the proper units. Last thing, if you were given grams of oxygen instead of moles, you could just use the molar mass, right, and simply convert that to moles. That was a homework problem that a few people asked me about. So don't be tripped up if you're given grams of a gas instead of moles. You just convert it to moles like you know how to do, and then you plug it right in. So we're actually good to go here, and we're just going to begin plugging everything in. So pressure, 1.6 atm on top times the volume, 27 liters, divided by, and this is where we plug in the number of moles of gas, 3.5 moles, times R, 0.0821 liters times atm per mole times Kelvin. So you have to make sure and triple check that the units work out. When you have something on top and something on bottom, it always cancels. So we should have one variable that doesn't cancel, and that should be Kelvin. We don't want Kelvin to cancel. So ATM is on top and bottom there, so they do cancel. Liters is on top and on bottom there. Moles, and on bottom here, moles, so those cancel. And then all we have left is Kelvin, which is perfect. So we're going to do 1.6 times the 27, and we're going to divide that by, oh shoot, I typed in the wrong number. 1.6 times 27 divided by 3.5 and divided by 0.0821. So my temperature is 150.3 if you round 3.4, and this is Kelvin. Okay, so there is an ideal gas law.